The dx is just going to be cos theta d theta. Sorry, I mean, it's kind of boring. I mean, it's kind of the same example as the first one, isn't it? Cos squared theta d theta, but this time we're looking at hyperbolic cosine squared, right? So I showed you guys two different ways to integrate this thing yesterday. I'm going to go ahead and say, well, this is 1/2 the integral of 1 plus cos of 2 theta d theta, which of course gives me theta over 2, plus 1/4 hyperbolic sinh of 2 theta plus a constant. And great. So that's not the answer yet, right? We need to go back to x's, right? So what is theta as a function of x? So notice if x plus 4 is hyperbolic sine of theta, then theta is inverse hyperbolic sine of x plus 4. So we can go ahead and 1/2 inverse hyperbolic sine of x plus 4 plus 1/4 sinh of twice the inverse hyperbolic sine of x plus 4 plus a constant. This could all be rewritten as algebraic functions and perhaps some logarithms. You'll forgive me if I don't do it at the moment. Also, you're like, so what about the test? I know. That would be the answer, okay? But a challenge question would be to try to rewrite this in terms of logs of algebraic functions. We saw how to write inverse hyperbolic sine as the natural log of x plus the square root of 1 plus x squared or 1 minus, I forget off the top of my head, but we did derive that, yeah.
Does that make any how you would form cos squared theta?
Yes, there is a hyperbolic identity that cos squared theta is 1/2 of 1 plus cos of 2 theta. This we've worked out in previous lectures. It is true. Okay, so I could show you the secant cubed there. I mean, it might be instructive, but I think it'll be distracting to at least 30% of the audience, so let me go on. Example 3. What if we were to do the integral of, let's say, dx over x to the 4th plus 4x squared plus 4. Now, at first glance, this might not seem like a trig substitution problem to you because there is no radical, right? But trig substitution is also useful for turning denominators into a single term, right? Like just a friendly reminder, if you have 1 over a plus b equals to anything, you're wrong. Okay, you're just almost certainly wrong, right? But on the other hand, 1 over a times stuff, well, this we can do things, right? 1 over a single thing, or a single squared thing. Oftentimes we're working with squares, or in this case, fourth powers. There's hope, right? So if we can get rid of a sum in the denominator and replace it with a single thing, or a single thing squared, that's a big step in terms of simplifying the integral, right? So what's the first step here? Factor, right? This is what? X squared plus 2 squared. So So what should we do with this x squared plus 2 squared? I mean, what should I do with this? So x squared plus 2, x squared plus 2. We could rewrite this as, well, 2 plus x squared. I don't think I've lost anyone, right? Okay. We could factor out a 2. Like so, right? And so if I want this 1 plus x over the square root of 2 squared to match one of my known patterns, what would I do? What are the contenders here? Star star again. Yes. So if we choose the star star path, oh right, it's the same pattern. I'm an idiot. So if we use star star, that would suggest that x over the square root of 2 is equal to sinh of theta, or what's the other substitution that seems hopeful? If we want to make this 1 plus something squared become a single square, we do what? X over root 2 equal to what? Tangent theta. I'm not sure which one's better. Let's do the tangent theta since we haven't done that yet, all right? For a given problem, there are certain problems where the hyperbolic substitution works out way easier. Example 2 is that, all right? If I give you the square root of something plus a variable squared, you want to make a hyperbolic substitution. If I'm being nice, I will say in the problem instructions, make a hyperbolic substitution. Because to not do such leads you to the integral of secant cubed, which will stump most of you on the test, right? Will stump me most days. That's not true. I've seen it too many times. It's stuck in my memory. Don't ask me when my children were born. Example one, I think trig substitution is pretty nice. I think if you tried a hyperbolic substitution there, it might go badly. All right? So there's some problems that are good for trig. There's some problems that are good for hyperbolic. Which is which? You gotta experiment. Okay, so we decided that we're going to do this one. If we do that, what do we got here? So x squared plus 2 is equal to, another way of writing this would be what? X is equal to the square root of 2 tangent theta, right? And so we've got square root of 2 tangent theta squared plus 2, which is also known as 2 tangent squared theta plus 2. Factoring out the 2, I've got 2 times tangent squared theta plus 1, which is what? Yeah, 2 secant squared theta. So I have 2 secant squared theta That's my x squared plus 2. That whole thing still squared, right? What's dx equal to? I'll write it up. I don't know. Over here, right? Dx is equal to square root of 2 secant squared theta d theta. Right? Derivative of tangent is secant squared. All right. This looks promising. We've got square root of 2 secant squared theta d theta. Now, how does this simplify? Let's pull the constants out front. What are the constants? We've got a square root of 2 divided by a 4 integral of, oh, look at that. So we've got secant squared theta d theta over secant to the 4th theta, right? How does that simplify? Looks like we've got a 1 over secant squared, right? What is that? What's 1 over secant squared? Sine squared. I got a sine squared. I got a tangent squared. Any other guesses? Let's see here. What's that? I heard a cosine squared. I will take the cosine squared theta. I mean, we can all agree to disagree, right? After all, truth is relative, right? I mean, there's lots of answers to a given math problem, right? I mean, there was this answer, and there was that answer, right? Truth is relative. I'm kidding. I mean, there are questions of style, right? Like, it's debatable. These jeans with the holes in them. Does anyone like these? I'm sorry if you're wearing them right now. But like, what if I take a knife, right? If I take a knife and I start carving some holes in my jeans, will that increase their value? I'm not sure. What if I found a local celebrity and had them cut the holes in the jeans, right? Oh, they have to wear the jeans for me, or they?
Yeah, if you cut a pair of jeans out of their size and you give them the jeans, they would be more valuable after they wore them.
After they wore them. What's that? If they weren't cut, it's just the process of the celebrity wearing them. Yes. Yes. Well, you've all taught me something today. Let's see here, 2 over 4. Let's make that an 8, and let's trade that for an integral of 1 plus cosine 2 theta. Because look where we've gotten to again. Cosine squared, right? So 4 times 2 is 8. And so great. Square root of 2 over 8 theta plus 1/2 sine 2 theta plus a constant. You'll forgive me if I don't write the algebraic answer this time, but this is 2 over 8. What's theta? Oh, well, maybe I should, though. There's no time. Theta is equal to? Inverse tangent of what? X over root 2 in this case, right? So we have inverse tangent of x over the square root of 2 plus 1/2 the sine of 2 times the inverse tangent of x over root 2. Close big parentheses plus a constant. There you go. So we can integrate 1 over a quartic if we can factor that thing, and it happens to be a perfect square. We make a trig substitution. There it is. We could change that sine of 2 theta term to an algebraic function. What would it be? What's the triangle for this substitution? What was my substitution? It is tangent theta is x over the square root of 2, right? So what's that make? That's the opposite and the adjacent. So one triangle, which, codifies the substitution, if you will, is this. And what's the hypotenuse? It's the square root of what? X squared plus 2, right? And so sine of 2 theta would be what? 2 sine theta cosine theta, which in this case would be 2x over the square root of x squared plus 2. Cosine theta would be square root of 2 over the square root of x squared plus 2. So you can see that in this case, that would simplify to 2 root 2 times x divided by x squared plus 2. So we could rewrite the last kind of half of that answer as that algebraic function, of course taking into account the fraction that's sitting over there in the brown. Anyway, we will do more of these, but this is basically the idea.